Okay, hello and welcome. Eitan Suez here with Solo.io. I'm a technical marketing manager, and in this lesson we're going to talk about kgateway in a very particular context, using kgateway as a waypoint in Istio ambient mesh. And so before we dive into the example of this lesson, it's important to perhaps review the context in which we're discussing kgateway here. We're talking about Istio ambient mesh. So let's do a quick review of ambient. Ambient mesh, as we may or may not know, has two distinct layers at which it allows you to configure things. One is layer 4, the TCP layer. And at that layer, the way we work with Istio in ambient mode is by deploying our workloads as we normally would. We don't have to restart or inject any sidecars. We use a label to actually designate which workloads we want to make part of the mesh. And the way it works is a component of Istio named ztunnel is our layer 4 proxy, is proxies traffic, networking traffic inside the cluster in a way that gives us workload identity and mutual TLS out of the box, which is one of the predominant reasons for adopting Istio. Now, if we want to avail ourselves then to higher level protocols, layer 7 protocols like HTTP, then we have the freedom to use what we call a waypoint. A waypoint being sort of a proxy or a gateway that's internal to the cluster. It is not concerned with ingress traffic as in comparison to other scenarios we've explored with kgateway in the past. We use the waypoint is implemented or provisioned using the Gateway API's gateway resource. Like we would normally configure an ingress gateway, we would configure a waypoint in a very similar way. We could define routing policies or traffic management or security policies and so on to control traffic inside our mesh. And we associate the waypoint that we create with specific workloads that we wish to proxy using a specific conventional label. Again, here it's called the use waypoint label. And then Istio ensures that requests get routed through that proxy and enforces whatever policies we've applied. So that's, in a nutshell, how ambient mesh functions. So what are we going to talk about? We're going to talk about provisioning a waypoint with kgateway. That is, instead or in lieu of using Istio's default waypoint, we can actually have kgateway stand in as that proxy. Now, why would we want to do that is something we'll get to very soon. But the mechanism involves essentially using a specific gateway class that kgateway provides out of the box called the kgateway waypoint gateway class. And so when we've provisioned gateways before for ingress purposes, we can provision waypoints with kgateway by simply switching the gateway class name. So how are we going to explore this capability? Through a demonstration. We'll jump into it in just a moment. We're going to step into an environment with a Kubernetes cluster and a kgateway pre-installed, and we're going to proceed to install Istio. And then to essentially realize this illustration here, we'll deploy a sample workload, HTTP bin, a sample application. We'll make it part of the mesh by labeling its namespace. And then we'll provision a kgateway waypoint. And then we'll instruct Istio to use it instead of the default one that Istio would normally provision to proxy that specific workload. And then we'll configure something that is specific to the capabilities of kgateway to demonstrate the advantage. And that, finally answering that question, the advantage of using kgateway as a waypoint is that there are features in kgateway that are not necessarily supported by Istio out of the box. And so that's the reason we do it. So let's step into our little sandbox environment here and demonstrate what I mean by all of this. So we'll begin by installing Istio in ambient mode on the cluster that's already running in this environment. And then we'll proceed then to deploy a workload. And I mentioned we'll use the HTTP bin sample application as the example workload, and that will work just fine. We'll just apply it straight from the repo. And then we'll proceed then to make that particular workload a part of the mesh, and we do that by labeling the namespace it's in with data plane mode equals ambient. All right, so if we then turn a page, so to speak, and look at the gateway classes defined on our Kubernetes cluster, we see both a set of gateway classes provided by Istio and one in a set provided by kgateway. And you see there the last entry, the kgateway waypoint, is the one we're going to be using. So if we look at this particular gateway resource definition or specification, I call it the turbo waypoint because it has some extra capabilities. And by using that gateway class name and the listener, we're told to use the listener on a particular port 15088. That's the convention with the protocol istio.io/proxy. We can provision our own waypoint and ask kgateway to provision it for us. So let's go ahead and do just that. Now, as you know, with the Gateway API, when you apply a gateway resource, you end up with a deployment and a service and a pod, and there it is, that turbo waypoint. Now, that waypoint is not yet configured to proxy traffic to HTTP bin, and so we'll do that by labeling our namespace with use waypoint equals turbo waypoint. We're saying any workloads in that particular namespace should be proxied by this particular waypoint. And then finally, we'll go ahead and attach a route. Now, there's nothing really particularly interesting with this route, but it's the first step in a sort of a two-step mechanism. Let me explain what I mean by this. This route basically says that requests destined to the service HTTP bin should be forwarded to HTTP bin. So that's almost feels like a no-op, which it is. But by attaching a route policy, maybe I'll bring this to the top of the screen so you can see it better. I call this route policy a transformation. Now, this is not part of the Gateway API. This is not something Istio understands. This is a resource provided by kgateway, which allows us to do a variety of things. Among them, perform different request or response transformations. And here what I'm doing is using a feature of kgateway, which allows you to do request transformations, whereby if there is a header by the name of message, we can maybe inject an additional header called x-decoded message, that decodes, base64 decodes the value of that other header. So that could be a plausible sort of scenario where we want to perform some kind of request or response transformations in the path of request to HTTP bin. Now we can apply this particular route policy, and then we'll proceed to deploy a sample client, a pod running curl or curl image, so that we can send requests from that pod to the HTTP bin workload. So if we define an environment variable called message like this, like so, that encodes hello world in base 64, then we can send from the curl pod, which we have running here, you'll see the curl pod, a request to the HTTP bin service. Here, let me just copy and paste it before we run it, with a header name message with the value being that base 64 encoded value. Now we're going to call the endpoint /headers on HTTP bin, which its job is to essentially echo back the information about the request, and we'll be able to see the headers that sort of came into the request to HTTP bin. So if we send in this request, we can see the message header that we sort of supplied in our request, but you'll also see an additional header, the x-decoded message. It's about halfway down, right around here, with the value hello world decoded from that base 64 encoded message. So the request transformation is working. And that's essentially an illustration of why we might want to use kgateway as a waypoint to avail ourselves of these particular kinds of features. And so if we sort of go back to and conclude our presentation or a lesson by pointing out the essential things that we get out of this sort of exploration is, one, Istio accommodates pluggable waypoints, and that we can use kgateway as a waypoint in Istio. And the reason we might want to do it is because there are features in kgateway that we might want to be able to take advantage of, not only in the use case of ingress, but also in the use case of east-west traffic, which is part of the promise of this omni-gateway, the fact that we have the tools now to control traffic and networking both at ingress or for egress scenarios, and as well as east-west scenarios. So if you recall, if you've used Istio in the past, back in the days, you often might have had to resort to using an Envoy filter to, for example, configure rate limiting or some other capability that wasn't natively supported in Istio. Well, kgateway brings with it a host of capabilities that we can take advantage of, and now we can apply those capabilities not only at ingress but also in the mesh, and that's the point of this capability. All right, so that concludes our lesson. Thank you for your time as always, and we'll see you in a future lesson.